Hello everyone, welcome to the today's lecture. Today we are going to start a new topic, that is CMM, Construction Material and Management. Basically, this subject as a name suggests there includes two topics in it, that is materials and then management. This subject consists of mainly two topics, or in this subject we deal two topics. One is related to the materials and another is management. Now in materials category, we study about cement, no doubt. We study about cement and then concrete, brick, finally about timber. Okay. So these are the materials we are going to study here. Cement, concrete, brick and timber. Obviously these are the materials that are used in construction or for buildings. And in management, we study about PERT and CPM. In management, we study about PERT and CPM. So PERT is nothing but a project evaluation review technique, whereas CPM is critical path method. Right. So these are the contents of this subject. Purpose of the subject, what we are going to say. Now you take the total civil engineering. In our total civil engineering, this is one of the very easiest subject. So try to concentrate on this subject. Yeah. Here I'll begin first with the materials. In that materials, I'll start discussing the cement and then we'll go for concrete, then brick and timber. And after this, we'll begin the second part of this subject, that is management. There where we'll discuss about PERT and CPM. Okay, all of you? So here, I'll begin with cement. Cement. Cement is called as, okay, cement is called with one fancy name, that is Portland, ordinary Portland cement. Right. So in general words or in layman language, we call it as a cement. But say it is having one fancy name known as ordinary Portland cement. So cement means it is ordinary Portland cement. Ordinary Portland cement. OPC. Ordinary Portland cement, OPC. So why this fancy name is for cement? Because after setting, okay, after setting and hardening of the cement paste, it resembles the natural rock occurring in the Portland in England. Okay, occurring at the Portland in England. Because of that, cement is having a fancy name of this Portland cement. Okay, all of you. And the cement was manufactured by Joseph Aspdin. The cement was first manufactured by Joseph Aspdin. It means you can say the cement is invented by cement is invented by Joseph Aspdin. Joseph Aspdin. So this is a brief history about the cement. So cement is having a fancy name of Portland, and as I explained you why it is having that fancy name, and the cement was invented by Joseph Aspdin. But coming to the cement, here mainly from exam point of view, we need to understand, okay, from exam point of view, we need to understand what is exactly meant by cement and how it is manufactured, and during the manufacture, what are the methods are steps we follow and different methods of manufacturing, and what are the various ingredients that are present in the cement, and for those ingredients what are the basic raw materials. Everything we are going to discuss now. Okay. So cement, you take cement. So cement is an artificial building material. Okay, cement is what? Cement is an artificial building material. It is an it is an artificial it is an artificial building material. Building material, or you can say construction material. Okay, it is an artificial building material manufactured from manufactured from manufactured from the raw materials 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 that that primarily that primarily consists of that primarily consists of calcareous and argillaceous compounds. Okay, so this is what the meaning, or you can say meaning or definition of the cement. So what is cement? Cement is an artificial building material manufactured from the raw materials that primarily consists of calcareous and argillaceous compounds. So see here, calcareous and argillaceous compounds. So from this, what is very clear? Raw materials of cement. Okay, raw materials of cement are primarily consisting two types. Okay, raw materials of cement are broadly classified into two types. One is calcareous and another is argillaceous. Because of these calcareous and argillaceous compounds, okay, because of these raw materials that primarily consist of calcareous and argillaceous compound, cement has cohesion and adhesion property in the presence of water. So let me write that as well. So due to the presence of these calcareous and argillaceous compounds in the raw materials, it has it has both cohesion it has both cohesion and adhesion. It has both cohesion and adhesion in the presence of water. In the presence of water. Okay. So it has both cohesion and adhesion in the presence of water. And one more thing, see, the first part of our subject CMM is mainly theoretical in nature. So you please try to enjoy this story what I'm going to explain or discuss here, because it is theory, and some more numericals, or you can say no numericals, or very few numericals are present in first part, whereas in second part management, as there exist numericals. So as long as we are discussing first part of our current subject CMM, so it is more theoretical in nature. Therefore, be patient and try to enjoy the way of explanation. So everything here I'm going to explain with some reason as well. So try to understand the story behind it. So further the patience is required. Okay. If it is numerical and analytical part, then it is interesting, quite interesting. But here it is more theoretical. No or very few numericals are present. Okay. So coming to the calcareous, so examples of calcareous compounds are, so if you see the examples of calcareous compounds, so examples are limestone, chalk, etc. So the compounds that come under the category of these calcareous are limestone, chalk, etc. So these are the major compounds that we use in category of calcareous for the manufacturing of cement. Hence here you see limestone, chalk, they contain mainly calcium and magnesium. They contain mainly calcium and magnesium. Therefore, the ingredients that can be extracted or that are present in these calcareous compounds are lime, which is CaO, comma, magnesia MgO. So the ingredients that can be extracted for manufacturing the cement from this calcareous category are lime and magnesia. So next category here is argillaceous. So next is argillaceous. Now the examples, common examples of argillaceous compounds are clay, shale, etc. So these are the common examples of argillaceous compounds by which we prepare cement or we manufacture cement. Okay. Now the pure compounds are elements. Okay. Now the elements that are present in these argillaceous compounds are silicon, Si, aluminum, Al, and then some impurities may also present like alkalis, sulfur, iron. So these are the elements that are present in this argillaceous compound. And those elements are not present in isolated form. Instead, they are present in combined form. Hence, the ingredients that are expected from these argillaceous compounds are silica, that is SiO2, comma, alumina, which is Al2O3, comma, iron oxide, and then alkalis, so that is K2O and Na2O, and after that sulfur may present either in sulfur form or sulfur trioxide. So these are the ingredients that are extracted from argillaceous compounds. Okay, so from this you can say what are the ingredients of the cement that are required for the manufacturing, or you can say what are the ingredients that are present in raw materials which are used for the manufacturing of the cement. Lime. So see, lime, magnesia, silica, alumina, iron oxide, alkalis, and sulfur trioxide or sulfur, you can say. Okay, sulfur trioxide or sulfur. Hence, for remembering these ingredients, here I'll give you one code word. Okay, I'll give you a code or a code word. You please try to listen. So this code word is as per the percentage or proportion of the ingredients that are present in the cement. That is L psi mass. So this is the code word, you please remember. Okay, this is the code word, you please remember with respect to highest, or you can say with respect to descending order. Okay, with respect to descending order of percentage of constituents present in or ingredients present in manufacturing of the cement. So here in L psi mass, L represent lime. Therefore, in cement, lime is present in major amount or greater amount. So here L represent lime, whereas S represent silica. So from this you need to understand the first major constituent in cement is lime, which is around 60 to 67%, and next silica, which is around 17 to 25%. After that it is alumina, which is further less, and then iron oxide, no doubt further less. Here M is magnesia. Here the A is alkali, because alkalis are present in very less amount. They are present in traces, right? So these alkalis are present in the cement due to the impurities. Okay, due to the impurities resulting from this clay or argillaceous compounds. Those impurities we can't remove. How sophisticatedly we may carry out the manufacturing of the cement. Okay, how precisely and sophisticatedly we may carry out the manufacturing of the cement. Still, some impurities in the form of alkalis are present in clay. Okay, therefore they are present in traces. Actually, they are unnecessary elements, but still they are present in cement. So in the same way, this sulfur is also present. Now, are you clear about the ingredients present in the cement in descending order, starting from lime to sulfur? Please respond. Are you clear about this? L psi mass, right? L is lime, S is silica, A is alumina, and then I is iron oxide, M is magnesia, MgO, A is alkalis, and S is sulfur or sulfur trioxide. Okay, so now here let us try to understand function of each ingredient in cement. Percentage, amount of percentage present in the cement and its function. It means what exactly this ingredient contribute to the cement and what happened if it present in excess. Now let us discuss about that. Okay. Before going into that discussion, here let me explain you the reason or cause for the adhesion and cohesion. I think you are aware of what is meant by adhesion and cohesion, right? Here we are written cement has both adhesion and cohesion. So in our discussion of soil mechanics, okay, in our discussion of soil mechanics, I'll explain you what is meant by cohesion and adhesion. So both cohesion and adhesion are attractive forces. Okay, if the attractive forces is between same molecules, then it is cohesion. If it is between different molecules, then it is adhesion. That's it. So example, you take pasting a sticker to a wall is known as adhesion. It means the gums and gels that are available, adhesives, okay, that are available in the market are adhesives like Fevistick, Feviquick. All are adhesives because they are developing attractive force between two different surfaces. Whereas you take cohesion is the internal property. In soil, even in fluid like water, there is a cohesion. So there where the attractive force occurs between the same molecules. Clear all of you what is meant by cohesion and adhesion? So please try to respond. As I said, this is the theoretical topic. You need to be very attentive. You need to be very attentive because here no numericals and analytical part is present. So please keep on responding. So as I said, before going into the discussion of these ingredients, let me explain you the reason of adhesion and cohesion. In cement, adhesion is due to calcareous compounds and cohesion is due to argillaceous compounds, that is clay. In cement, adhesion is due to calcareous compounds. Calcareous compounds such as limestone, chalk, etc. Because these calcareous compounds mainly consist of lime, so which impart adhesion or binding property, you can say. Okay, that is why the adhesion is due to calcareous compounds. Is due to calcareous compounds such as limestone, okay, such as limestone, chalk, etc. Whereas cohesion is due to, as already discussed in our geotechnical engineering, cohesion is the inherent property of fine grained soil such as clay, right? The same here also. Cohesion is due to argillaceous compounds. Cohesion is due to argillaceous compound or materials, you can say. Argillaceous materials like clay. Okay, now? And one more point, you please try to understand. So standard density, or you can say bulk density. So in soil we discuss this density with a word known as bulk density, but here we call it as standard density. So density, standard density, standard density means bulk density. Okay, bulk density what we have discussed in soil. So standard density of cement is 1440 kg per meter cube. So standard density of cement or bulk density of cement is how much? 1440 kg per meter cube. So from this can we calculate volume of cement present in one bag? So generally one bag will have a weight of 50 kg, right? So one bag of cement will have, so one bag of cement is having how much weight? 50 kg. So density is known to us and obviously the weight is known to us. Therefore, the volume of cement present in one bag is how much? This 50 divided by 1440. So this comes out to be 0.035 meter cube, which is 35 liter. Okay, which is 35 liter. Okay. So one bag of cement is having how much volume of cement? 35 liter. Because one bag of cement weighs 50 kg and standard density is 1440 kg per meter cube. Clear all of you with this concept? So please try to respond. Clear all of you? Yeah. So next. Sorry, able to follow what I'm trying to explain? Okay. Now here let us see functions of the ingredients that are present in cement. So chemical composition. Chemical composition. Chemical composition of raw materials. So this chemical composition consists of various oxides. What are those oxides? L-SiMas, right? So chemical composition of raw materials. So this chemical composition consists of various oxides. Those oxides are obviously L-SiMas. Okay. So you please remember this code word L-SiMas. So generally these oxides interact with one another in a kiln at high temperature to form more complex compounds known as Box compounds. We'll discuss about that Box compounds little later. You don't worry. Okay, we'll discuss about those Box compounds little later. You don't worry about it. But as of now, you concentrate on the oxides. Okay, concentrate on these oxides. So first here is lime, right? First one is lime. So lime present around 60 to 67% by weight of the cement. Okay. So after manufacturing, if you see the lime is present around 60 to 67%. And the purpose. So the purpose of this lime is to impart binding and strength. So this lime present in the cement. So this is the function. Let me mention that. Function. Function, or you can say purpose. So purpose of this lime in the cement is that it imparts binding and strength. So lime imparts binding and strength. Okay. But excess of lime causes unsoundness. So excess of lime causes unsoundness. The word you see, the terminology. What is meant by unsoundness and soundness? I'll explain. Here itself you listen. So excess of this lime causes unsoundness. So what is meant by this unsoundness? First you please try to understand, and later we'll discuss about how the excess of lime will cause unsoundness, unsoundness, unsoundness. Delayed increase in volume, delayed increase, delayed increase in volume. Okay, delayed increase in volume or slow increase in volume is known as unsoundness. Then what is meant by soundness? Soundness means no volume change. Then what is meant by soundness? Soundness means no volume change or no volume increase. No volume increase. Okay. So unsoundness is nothing but delayed increase in volume and soundness is nothing but no volume increase. Now coming to the lime. As we know, lime chemical formula is CaO. Okay, lime chemical formula is what? CaO, which is called as quicklime. Okay, lime chemical formula is what? CaO, which is called as quicklime. Why it is called quicklime? Because it is having higher FTD towards water. Now the moisture content that is present in atmosphere or water that is present in cement, okay, excess of water that is present in cement will cause this unsoundness due to lime because this lime is having higher FTD towards water. Therefore, lime react either with moisture content present in the atmosphere or moisture content that is present within the cement and it forms CaOH twice or slaked lime. So lime react with water and it gives rise to slaked lime. Just a second. So lime reacts with water and it gives rise to CaOH twice. So both are called as lime, but this is called as slaked lime and this is called as quicklime chemically. In chemistry, we study about it. Okay. So the volume of the CaOH twice is more than the volume of original lime. So if excess lime is present, then that excess lime reacts with water content or moisture content present in either in atmosphere or within the cement mass and it gives rise to CaOH twice, which is having more volume than original CaO because here the lime or CaO main function is to impart strength and binding. How the lime will impact strength and binding I'll explain later. So that is the main function. For that lime required is 60 to 67%. But if lime present is more than this amount, maybe 75% of lime is there, then whatever the excess is there, than the required. So that excess of lime react with the moisture content present either in the atmosphere or within the cement mass and it gives rise to CaOH twice, which is having a more volume. Okay, the CaOH twice is having more volume. So this is more volume, more in volume, more in volume than CaO. Hence, it causes unsoundness. Unsoundness means increase in volume. So, because of this increase in volume, cracks will occur. So, these cracks will ultimately reduce the strength, right? If there is a crack, then obviously there is no point to point contact or grain to grain contact. As the grain to grain contact get disturbed, strength reduces. Clear all of you? So finally, this lime, excess of lime, causes decrease in strength. But the lime itself is introducing or inducing strength in the cement. But if that required constraint for the strength is present in more amount, then it will reduce that very same property it is inducing. Okay, then all of you clear? Please respond. So function of lime and excess of it. Then obviously deficiency of lime will also cause reduced strength, whereas excess of lime will also cause reduced strength finally. But the first it induce unsoundness. Because of that unsoundness, finally there will occur reduce in strength or reduction in strength. Okay, all of you clear? And one more thing I want to know from your end, are you able to follow and are you comfortable with the way how we are dealing this theoretical subject? Please respond. Are you able to follow all of you? Those who are online. And are you comfortable with the way what we are following? Okay then. Yeah. So next oxide is silica. Okay. Next important oxide is silica. Silica, SiO2. It is present in an amount of 17 to 25%. So in the cement, silica is present in 17 to 25%. So the silica present in cement will also induce binding and strength. So function of silica is same as that of lime. It means you please understand both lime and silica combinedly induces or produces binding and strength in the cement. Okay. So alone lime or silica will not produce strength and binding. So combinedly lime and silica will produce strength and cement. It means this lime and silica combine and they form calcium silicates. So two types of calcium silicates are going to form during the manufacturing process of the cement. What are those calcium silicates? We'll discuss in Book's compounds. So as of now, we are discussing chemical composition of or required chemical composition that should be present in raw materials of the cement. But after manufacturing also, we'll discuss about constraints of the cement. That is constraints that are present in the clinker. So in those clinker, there present Book's compound. So this calcium silicate is the combined component due to lime and silica that induce strength and binding. So two types of calcium silicates are present in the manufactured cement. That is tricalcium silicate and dicalcium silicate. We'll discuss about those tricalcium silicate and dicalcium silicate in detail. Don't worry. But as of now, you try to understand what I'm explaining. So combined silica and lime induce binding and strength in the cement. Not only lime or silica. Please make a note of it. So function is to impart binding impart binding and strength. Impart binding and strength. Now here excess. If silica is present in excess, if silica is present in excess, then it increases setting time. Then it increases setting time. Then it increases setting time. Now what is meant by setting time? Here one more term is there, setting time. Increases setting time means slow setting, that is slow setting. That is slow setting. So see, what is setting time also I'll explain in detail in our latter part. Okay, in our latter part of this cement discussion, I'll explain about the setting time. Basically, there are two types of settings. One is initial setting time and another is final setting time. Everything is going to be dealt in detail. But as of now, you please try to understand briefly what is meant by setting. So setting is nothing but losing plasticity present in the cement. Okay, losing plasticity present in the cement. It means for the cement to gain strength. Okay, for the cement to gain strength or for the cement to get harder, we need to add water in it, isn't it? That is known as hydration of the cement. So without the hydration of the cement, there is no development of strength and binding nature of the cement. Okay. After adding water to the cement, it become like a paste. Right? It became like a paste having some consistency. Now losing that consistency or plasticity or fluidity nature. Okay, losing that fluidity characteristic or nature, which is called as plasticity, is known as setting time. Okay, setting time. Now, excess of silica will increases the time taken for losing that plastic property. Why? Because silica is obtained from clay, right? Silica is obtained from clay. So, in geotechnical engineering, we have discussed in detail about plasticity property of fine grained soil, right? Did you remember that? So I explained you in detail about the plasticity property, which is mainly due to the presence of clay mineral like montmorillonite, illite, kaolinite, and also due to the presence of adsorbed water. Okay, so if more silica is present, then it indicates that more clay is present in that cement. Therefore, more amount of plasticity is also present, and so more time is required to lose that plasticity. Simple. That is the reason for slow setting if excess of silica is present in cement. Okay. So more amount of silica represents more clay. Represents more clay. So more amount of clay further represent more plasticity. As the plasticity is more, and more time is required for it to vanish, and increases setting time. Okay. So next ingredient, a next oxide that is present in cement raw materials is what? Alumina, Al2O3. The third one is alumina. Alumina. Now the percentage of this alumina is around 3 to 8. The percentage of this alumina is around 3 to 8. Okay, 3 to 8. Now the function is to cause quick setting. Okay, alumina induces quick setting. This induces quick setting or imparts quick setting, causes quick setting. If more aluminum is present, then less time is required. Okay, less time is required to lose that plasticity. Okay, it causes quick setting. But the excess of alumina, but the excess causes plastic shrinkage and reduced strength. Excess causes plastic shrinkage. Shrinkage means reduction in volume, right? Shrinkage means reduction in volume. Shrinkage means reduction in volume. Therefore, excess causes plastic shrinkage and reduction in strength. So, how the excess of alumina cause plastic shrinkage and reduction in strength? Let us try to understand. So, the main function of alumina in cement is to cause the quick setting. So as I said, as I explained earlier, setting is nothing but time taken to lose plastic property or plastic nature of the cement when it is mixed with water. So for getting the strength of cement, water is to be added, known as hydration. So hydration of cement is well required or it is mandatory for the development of the strength. During that hydration, or hydration of cement is basically exothermic process. So during that hydration, heat is been evolved. Okay, it means when water is added to the cement, ingredients that are present or oxides that are present in the cement will react with it, react with the water. So lime react with the water, silica react with the water, as well as alumina will also react with the water. But out of all these constants, alumina is the one which react with the water at first. Okay, which react with the water at the first. So alumina reacts with the water at first and it releases a high heat of hydration. Okay. So here there are two terms, rate of hydration. So here coming to the hydration also, I'll explain you in detail. Don't worry. I'll explain you about the hydration and everything in detail, setting time, hydration, everything I'll explain. So rate of hydration. So rate of hydration means reaction rate. Okay, reaction rate of ingredients of the cement. So rate of hydration of alumina is greater or it is very high. Okay, rate of hydration of alumina is very high. And also this hydration of cement is exothermic process, means heat is evolved. Therefore, heat of hydration is also more. Heat of hydration is also more. That is heat evolved during the hydration. So this you can observe practically as well. When you add water to the cement, then some heat is going to be evolved. That is known as heat of hydration. So out of all the constants, heat liberated, okay, heat liberated by the reaction of the alumina with water is more. Hence, heat of hydration is also more. Heat of hydration is also more. Because of this more heat of hydration, okay, because of this more heat of hydration, water that is present, okay, water that is present will evaporate after the completion of the hydration process of alumina itself. Because here hydration of cement means it is the hydration of all the constituents present in the cement. But among all the constituents, alumina is the one which react with the water at first. And that reaction process is also very fast. and during that fast process of reaction, greater amount of heat is going to be evolved. Okay, so here we add water to the cement by keeping in the mind by keeping in a mind that hydration of total constant should occur. Okay, by keeping in a mind that hydration of total cement to occur, we add some amount of water to it, to the cement. But at first, alumina will react with it, and that reaction rate is fast, as well as more heat is evolved. So that evolved heat will evaporate the water that is present in the cement, which is required to carry out the hydration of the other compounds. But because of this high heat of hydration, that extra water is going to be evaporated, so that hydration process will incomplete. So that hydration process will be incomplete. If hydration process is not completed, then the strength is not going to develop. In this way, it reduces the strength. So because of this heat of hydration, more heat of hydration, water that is present is going to evaporate, which could otherwise react with the other components of the cement for a total hydration process to complete, for giving the strength. So water is going to be evaporated. So water evaporates. Water evaporation will occur. So water is going to evaporate, and there is a reduction in the volume, and that reduction in the volume is occurring when the cement is in plastic state. Therefore, technically it is called as plastic shrinkage. So why it is called as plastic shrinkage? Because here the reduction in volume is occurring due to the evaporation of the water when cement is in plastic state. Hence it is called as plastic shrinkage. Clear? So this will lead to the plastic shrinkage as well as incomplete hydration. Incomplete hydration. Since the hydration process has not occurred completely, then full strength will not develop, or reduction in strength is going to be observed. So incomplete hydration and reduced strength is being observed. Now clear with this point? Why the excess of alumina causes plastic shrinkage and reduction in strength? All of you clear with this? Okay. For the next one. So next is iron oxide. Next is iron oxide. That is Fe2O3. So this iron oxide is present in an amount of 0.5 to 6%. Okay. So the function of iron oxide is to impart color. Color of the cement is due to iron oxide, and as well as it induce strength indirectly to the cement. So what is the function of this iron oxide? Imparts color. So color of the cement is due to iron oxide. Imparts color and strength indirectly. So this iron oxide introduces or induces strength indirectly, but not directly like lime and silica. So lime and silica are the constituents which directly induce strength to the cement, whereas this iron oxide induce strength indirectly. So how the iron oxide induce the strength indirectly, and how the iron oxide induce the cement, let us discuss. So impart color and strength indirectly. So impart color and strength indirectly. So see, generally iron oxide is reddish in color, right? So color of iron oxide is what? Color of iron oxide is reddish, reddish, which is present in a percentage of 0.5 to 6%. Whereas in the very same cement, lime is present in 70%. Okay. Lime is present in how much? 70%. So not exactly 70%, it is 60 to 67%. So approximately 70%. So color of lime is white. Now the color of cement is due to the mixture of this reddish and white color. And finally, the combination of this reddish and white color appears like a gray. Okay, appears like a gray color. Okay. Okay. So it is greenish gray. So greenish gray color of the cement is due to the combination of reddish color from the iron oxide and white color from the lime. Okay. And how this iron oxide introduces strength indirectly? This iron oxide, okay, this iron oxide imparts strength indirectly by fusing correct proportion of lime and silica for the formation of calcium silicates, that is tricalcium silicate and dicalcium silicate, right? So in the absence of iron oxide, okay, in the absence of iron oxide, fusion of lime and silica do not occur properly and the strength will not develop due to the non-formation of calcium silicates. So in that way, iron oxide is contributing strength indirectly. Okay. So iron oxide. So Fe2O3 imparts strength indirectly. So FeOT, Fe2O3, Fe2O3 makes fusion of lime and silica in correct proportion. In correct proportion. In correct proportion. So for the formation of calcium silicates, for the formation of calcium silicates. So calcium silicates are the compounds which produce strength in the cement. So there are two types of calcium silicates, as I said, tricalcium silicate and dicalcium silicate. As of now, you don't worry. We'll discuss about those calcium silicates which are box compounds later in this cement topic itself. Okay. So this is the reason why the white cement has no strength. So I think you are aware of the white cement, right? So white cement being white in color, it has no iron oxide in it. Hence it has no strength. Even though white cement and OPC, ordinary Portland cement, will have the same amount of lime and silica in it. Still, white cement has no strength because of absence of Fe2O2, Fe2O3. Clear? So if there is no Fe2O3, then calcium and silica will not fuse in correct proportion for the formation of calcium silicates, and there is no development of strength. Clear, all of you? So for the white color in white cement, we remove iron oxide. Hence, there is no strength in the white cement. Therefore, white cement is not used for regular construction. Basically, it is used for putty work and for aesthetic purposes. Okay, all of you clear? This is about the iron oxide. So, the next oxide, magnesia. Next oxide is magnesia. MgO. Next oxide is magnesia MgO. So, it is present in 1 to 4%. Okay. So, this magnesia imparts hardness and also yellow tinge color. Yellow tinge color. And excess of this magnesia causes unsoundness. Excess causes unsoundness. Excess causes unsoundness. So how this magnesia cause unsoundness? If more magnesia is present, then that magnesia will present that more or excess magnesia present in cement will react with sulfate formed from the sulfur present in cement, and they gives rise to magnesium sulfate. This magnesium sulfate is obviously more in volume than original magnesia, hence it causes unsoundness. Clear? So that is what the function and excess of magnesia. After this, alkalis. After this, alkalis. They are mainly K2O and Na2O. So these alkalis are present in the cement due to the impurities of the clay. Okay, due to the impurities present in the clay, these alkalis are also present in cement as a trace elements. So they are unavoidable. Okay, they are unavoidable. Therefore, there is no particular function of alkalis, but these particular alkalis causes efflorescence and cracking. So if excess, so alkalis has no function. Okay, alkalis has no function. But if they are present in excess, excess causes efflorescence, and subsequent cracking due to that efflorescence. Now, what is meant by that efflorescence? Let us try to understand. Okay, what is meant by that efflorescence? Let us try to understand. So these alkalis present in the cement are no harm if they are in dissolved form in water. Okay, as long as alkalis present in the cement are in dissolved form, then they are not harmful. But once the water get evaporated, or once the water get finished after the hydration, then these alkalis will appear onto the surface as a solid or precipitate, and they remain on the surface. Because of these remainings of alkalis on the surface of the cement, it appears like a white patches known as efflorescence. And if that greater amount of white patch is present, it will lead to the cracking. Okay, it will lead to the cracking. So percentage of alkalis is around 0.4 to 1.3. Okay, so this is the percentage of alkalis. Right, so let me write that point. So alkalis present in cement are no harmful if they are in dissolved form. So alkalis present in cement, alkalis present in cement are of no harm if they are in dissolved form. If they are in dissolved form, in water. But once water gets evaporated, the alkalis are left behind in cement and appears on surface as white patches known as efflorescence. Now clear what is meant by efflorescence? You please remember this word, because the very same word again we are going to study in brick as well. Okay, in brick we study, even in concrete also we study, but mainly we study it in brick. So clear all of you what is meant by efflorescence? Now the last one here is sulfate or sulfur, obviously. So sulfur that is present in cement is in the form of sulfur trioxide. The form of sulfur that is present in the cement is as sulfur trioxide. Sulfur. This sulfur in the form of sulfur trioxide present in 1.3 to 3%. So generally it makes cement sound. Cement sound means no volume change, but excess is present, then obviously it makes the cement unsound, like lime. So if lime is present, then it imparts strength, but if excess lime is present, then obviously it reduces the strength, as explained. Similar kind of function here for sulfur as well. So make cement sound. Excess causes unsoundness. Excess causes unsoundness, and this unsoundness caused by the sulfur sometimes we ignore because the amount of sulfur present in the cement is very less. Therefore unsoundness caused by the sulfur alone can be ignored. Okay, unsoundness caused by the sulfur can be ignored. Now what are the constants that causes unsoundness? You see, this can be expected as object to question. So what are the constants of cement that causes unsoundness? The first and foremost is no doubt lime, because it is present around 65% approximately. And next to lime, unsoundness is also caused by magnesia. Okay, so major amount is lime. Okay, major amount of unsoundness is due to lime. Next is magnesia, which is very less. And after magnesia, it is due to sulfur trioxide, which is even further less. Hence, we ignore unsoundness caused by the sulfur. Clear with all these various oxides that are present in the raw materials of the cement, all of you? So, what are the various oxides? Once again, I'll repeat: calcium oxide, sulfur dioxide, aluminum trioxide, ferric oxide, magnesium oxide, alkalis, that is sodium and potassium oxide, and sulfur trioxide, LCIMAS. And these are the functions. So lime is present in more amount or greater amount or major amount in cement, that is around 60 to 67%, which imparts binding and strength, and excess causes unsoundness, which is what I explained in detail. And later coming to the silica, so silica is present in 17 to 25%, which also imparts binding and strength. Therefore both silica and lime combinedly imparts binding and strength to the cement. And for that impartion, okay, for that strength to be produced in the cement, they require iron oxide. Please make a note of that point as well. Now the excess of silica will increase as the setting time, the reason I explained. Now coming to the alumina, it is present in 3 to 8% and causes quick setting. Quick setting means you can say quick setting also as flash set. So this alumina immediately react with water upon adding water to the cement, and reacts with it and releases high heat of hydration, so that quick setting will occur. And excess of alumina causes plastic shrinkage and reduction in strength, which is what explained here. And iron oxide introduces color and strength indirectly. After that, magnesium hardness and yellow tinge color causes unsoundness. Alkalis efflorescence. Sulfur sound and excess causes unsoundness. Clear all of you? Please respond so that I'll proceed to the next, that is manufacturing of the cement. So I proceed to the next, that is manufacturing of the cement. So next is manufacturing of the cement. So here let us see how the cement is being manufactured and what are the methods and steps in it. manufacturing. Manufacturing of cement. So cement is a product. So let me write. Cement is a product. Cement is a product Cement is a product obtained. Cement is a product obtained by pulverizing, by pulverizing clinker, by pulverizing clinker formed by calcinating raw materials, by calcinating raw materials. Okay, so this is how the cement is manufactured. Here some keywords, you please try to sense the keywords. So cement is a product obtained by pulverizing. Then what is meant by pulverizing? We need to discuss. Clinker. So what is meant by clinker also we need to discuss. And calcinating. And one more keyword is also there, that is raw material. Already we have discussed about these raw materials. So raw materials are broadly classified into two groups, that is calcareous and argillaceous. Calcareous examples are either limestone or chalk, and argillaceous are either clay or shale. Now these raw materials mainly consist of various oxides, that is LCMS. So coming to the raw materials, already we have discussed. Now what is meant by pulverizing? What is meant by clinker? What is meant by calcinating? Let us try to understand here. So pulverize. So pulverizing is nothing but breaking and grinding into a powder. Okay, so breaking and grinding a solid or a hard mass into a powder is known as pulverizing. So what is meant by pulverizing? Let me write here. Pulverize. So pulverize is nothing but make into a powder by breaking and grinding. Make into a powder by breaking and grinding. So this is the meaning of pulverize. Now what is clinker? Before that, let me write what is meant by calcinating. Calcination. Heating at high temperature. So calcination is nothing but heating at a high temperature. That is up to 1400 to 1600 degrees centigrade. Okay, so what is meant by calcination? Calcination is nothing but heating at high temperature. That is, the temperature is around 1400 to 1600 degrees centigrade. Then what is clinker? What is clinker? So clinker is a hard substance, is a hard substance, is a hard substance formed after calcinating the raw materials, after calcinating the raw materials in rotary kiln. Okay, so these are the words okay, these are the words what we have discussed here in the manufacturing of the cement. So pulverizing, what is meant by pulverizing? Pulverizing is nothing but make into a powder by breaking and grinding. Then what is calcination? Heating at high temperature, that is up to 1400 to 1600 degrees centigrade. So because of these heating of ingredients, there forms a hard substance, okay, hard rock like substance known as clinker in rotary kiln. That hard rock like substance has to be make into a powder form known as pulverization. So this is how the cement is been manufactured. Clear all of you? Now the steps involved in manufacturing. Let us see the steps involved in manufacturing. Steps. So there are 3 steps. One is mixing. It means the raw materials has to be proportioned and mixed to a required level. Okay, raw materials are to be proportioned and mixed properly to a desired level, and then we need to burn it. So burning, that is calcination, burning or heating of mixed raw materials, and finally grinding. After grinding we get a required product, cement. Okay, so during this grinding we add one more ingredient known as gypsum. So gypsum is being added. So during this step of grinding, 2 to 3% of gypsum is added. Okay, 2 to 3% of gypsum. What is the chemical formula of gypsum? CaSO4 2H2O, right? This is the chemical formula of the gypsum. So gypsum of 2 to 3% is added during the grinding. Therefore, after the formation of the clinker and during its pulverizing stage we add gypsum. Why we add gypsum? Because in cement there present alumina. Okay, there present alumina which induces flash setting. If flash setting is happening in a cement, then the proper strength cannot be produced and the desired properties can also be produced. Therefore, to retard the initial setting time or false setting, we add 2 to 3% of gypsum during grinding. Please make a note of it. Even this can also be expected as a question. I think this was asked in previous year gate. Okay, so here we add 2 to 3% of gypsum to retard setting caused by alumina. Okay, all of you. So these are the steps that are involved in manufacturing cement, that is mixing, burning and grinding. So manufacturing of cement can be done by two processes. That is wet process and another is dry process. So process. So two processes are there. One is wet process and the other is dry process. As the name suggests, in wet process, we mix the ingredients, okay? We mix the raw materials by making use of water. As the name suggests, in wet process, we mix raw materials that are required for the manufacturing of cement in wet condition by making use of water. Whereas in dry process, we don't use water for mixing. Instead, we use compressed air. Okay, instead we use compressed air. So here the wet process is a old process, right? For many years, the wet process remained popular because of the possibility of more accurate control in the mixing of raw materials. And also at that time, the techniques of intimate mixing of raw materials in powder form were not available. Hence, wet process was in use for very long time. But later, the dry process gained momentum with the modern development of the technique of dry mixing of powdered material using compressed air. Okay, all of you. So let me write that point. So from the name itself, you can try to understand it. For many years, for many years, the wet process remained popular. Remained remained popular. Remained popular because of the possibility possibility of more accurate control, in the mixing, more accurate control in the mixing of raw materials. Mixing of raw materials. Later, later, the dry process, later, the dry process gained momentum, gained momentum, gained momentum with the gained momentum with the modern development of the technique, modern development of the technique of dry mixing, Technique of dry mixing of powdered raw materials, powdered raw materials using compressed air. Clear all of you? So this is in brief about wet process and dry process. Now let us try to understand this wet process and dry process with a flow chart. Okay, with a schematic flow chart, let us try to understand wet process and dry process. So first one, wet process. Be it a wet or dry process, raw materials remain same. But the mixing of the raw materials decide the type of process here. So way of mixing. So here it is argillaceous, that is clay, and limestone, that is calcareous. So this limestone first we crush by using crushers. Limestone is being crushed by using crushers and taken into the storage basin. Taken into the storage basin. Now here the clay, whatever taken for manufacturing cement, is being admitted into wash mills, because clay consists of some pebbles, cobble, etc. Right? Some foreign elements it contains. So for that, we'll take that clay into the wash mill. After washing the clay, we take into the storage basin for clay. Okay, we take that clay into the storage basin. Now these two constraints from the storage basin is taken into grinding mills. There where by making use of the water, we prepare a slurry. So these two ingredients from storage basin is taken into wet grinding mills. Wet grinding mills to make slurry. Wet grinding mills to make slurry. Okay, wet grinding mills to make slurry. Now this slurry is been blended to the correct proportion, because raw materials that are expected to present should be in the desired percentage or desired proportion. Then only the required properties of the cement can be achieved. Because you see lime may present in 60 to 67%. So that range mainly depend upon the function for which the cement is being used. Okay, accordingly here in this step, blending of slurry to the correct composition can be done. Okay, so here blending of slurry to correct composition, that is a step. After blending the slurry to the correct composition, we take this slurry to the storage basin. We take it to the storage storage of corrected storage of corrected slurry storage of corrected slurry. Now this corrected slurry is taken to the rotary kiln. Now this corrected slurry is taken to the rotary kiln. There were burning at high temperature, that is around 1400 to 1500 or 1600 degrees going to be maintained. So rotary kiln. Rotary kiln. Now for the wet process, the temperature is around 1500 to 1600 degrees centigrade. So this is the temperature that is to be maintained in rotary kiln in wet process. Now for the burning, here we use fuel. For the burning, here we use fuel. That fuel is obviously powdered coal or a oil or a natural gas. So for burning, here we require a fuel, right? So that fuel is either powdered coal, oil or gas. After burning, this corrected slurry will become into clinker, right? This corrected slurry will become into clinker. So clinker is formed. Clinker is formed. Now this clinker is further made into powder form by grinding and breaking. Therefore, this clinker is taken into the ground, okay, taken into the ball mills where the clinker is grounded. Okay, clinker is ground in ball mills. So we'll take this clinker into ball mills for pulverizing. Okay. During this pulverizing process, we add gypsum. Okay, We add gypsum. We add gypsum to the cement. So here where the gypsum is being added. Addition of 2 to 3% of gypsum. Two to 3% of gypsum. After grinding and breaking, we'll get a cement, right? We'll get a cement which is taken into the silos, and this cement in the silos is taken to the packing plant, there where it is dispatched. So this is the schematic flowchart for wet process. Okay, all of you. I'll show again from the beginning. You please try to observe. So this is the wet process. So be it a wet or dry process, first we'll take those two raw materials separately. Here as it is a wet process, hence we grind them by making use of, okay, we mix and grind them by making use of water so that the slurry is going to be formed. After formation of the slurry, we'll blend it for the correct composition as per the requirement of the cement, okay, as per the required usage of the cement in the field. After blending that corrected composition of the slurry, we heat it in the rotary kiln by making use of a fuel in the form of powdered coal, oil or gas. Then clinker is formed. Okay, then clinker is formed. So formed clinker is being grinded, that is pulverized. During that process, we add gypsum, 2 to 3% of gypsum, so that initial setting time is going to be increased. That is retardation of quickset occurs. Finally, cement is being formed. Okay, finally cement is been formed. Now you see here the clinker. So what is clinker? So clinker is hard substance formed after calcinating of the raw materials, right? That is what we have discussed. So this clinker consists of, our chemical composition of clinker consists of Box compounds. That is what the point to be noted. So this clinker consists of what? Box compound. So chemical composition of clinker is known as Box compounds. It means after heating in rotary kiln, we get a clinker. So that clinker consists of a compounds known as box compounds. We'll discuss about that box compounds after completion of the manufacturing step. So this is what wet process. Okay, this is what the wet process. Now let us see the dry process. So all of you clear with this wet process? Okay, I'll proceed further. Next is dry process. Be it a wet or dry process, raw materials remain same. Okay, here it is clay. Here it is limestone. In dry process, water is not added. Therefore, these raw materials are first crushed. Okay, they are being crushed into a powder form. So, first in dry process, both the raw materials are being crushed separately. Now, these crushed raw materials are further fine grinded in a ball and tube mills. Fine grinding in ball and tube mills. Okay. After fine grinding, they are taken into the storage basin. As here the mixing should be done in dry form, hence the raw materials have to be grinded fine in two steps. One is the preliminary step, that is crushing, and later fine grinding in ball and tube mills. Both raw materials in different storage basins are now taken into a combined mixing basin. So now they are taken into mixing basin in correct proportion. So here both the raw materials from the storage basin are taken into combined mixing basin, there where the correct proportion is been set. Mixing in correct proportion. After mixing in the correct proportion, here the raw materials, or you can say raw gradients, are being preheated by exhaust gases. So preheating has to be done before taking those into the rotary kiln. Preheating is required. Then only the correct proportion is going to be sustained or remain. Preheating. Preheating at 800 degrees centigrade by exhaust gases. By exhaust gases. By exhaust gases. Okay. Then these correct mixed portion of dry raw ingredients are further taken into the storage tank. There where again mixing is done. So storage tank for raw mix. After this raw mix, we'll take this particular mix to the rotary kiln. Okay, here we'll take it to the rotary kiln. Rotary kiln, where the temperature is maintained around 1400 to 1500 degrees centigrade. Now you see, in this case, the temperature is less than 100 to 200 degrees centigrade because of dry mix. Hence, the height of kilns that are required in case of dry process are less in height. Even cost of fuel is also less because the less temperature is required. That is around 100 to 200 degrees centigrade. Okay. So fuel we add either coal, oil, or a natural gas. Okay. So from the rotary kiln, clinker is been obtained. Now this obtained clinker has to be pulverized, right? Pulverized. During this process of pulverizing, we add gypsum, right? Gypsum is being added. Then cement is formed, right? Cement is formed. After formation of the cement, we take it to the packing plant, there where it is dispatched. Okay. Okay, all of you. This is dry process. Okay, this is dry process. So we discussed the manufacturing. Now let us try to understand advantages and disadvantages of dry and wet process. So comparison of wet and dry process. Comparison of wet and dry. Comparison of wet and dry process. Comparison of wet and dry process. So dry process is economical. Dry process is economical. Is economical due to following. Due to following. So why the dry process is economical? The first one, less consumption of fuel. Less consumption of fuel in clean rotary kiln as raw materials are in dry state. So less consumption of fuel. Less consumption of fuel. Fuel in the kiln. And also shorter kilns are required. Shorter kilns are required to heat. Required to heat. So whereas if you see in dry process, kilns are of greater height, means longer kilns are required, which are costly, and even they are less responsive to the variable clinker demand. Okay. In wet process, in wet process, longer kilns are required. Longer kilns are required, which are costly and less responsive to variable clinker demand. So all these are self-explanatory, right? Based on the points what we have discussed so far. Next, you see the advantage of wet process. Advantages of wet process. So main advantage of wet process is that low cost of mixing. Low cost of mixing. Low cost of mixing and grinding of raw materials. Because in dry process we use compressed air and we carry out the mixing in two steps, right? And it is a costly affair. But here, low cost of mixing and grinding of raw materials. And one more advantage, accurate control. Accurate control of the composition. Accurate control of composition. Accurate control of composition and homogeneity. And homogeneity of the slurry. So these are the advantages of wet process. Clear all of you? This is all about the manufacturing of the cement. Okay, this is all about the manufacturing of the cement. So please respond. Are you clear so far? Next is chemical composition of clinker. Okay, next one is chemical composition of the clinker. Before that, I'll explain you the definitions of some terms here, and then we'll go for discussing chemical composition of the clinker. Plasticity. As we have already discussed about this plasticity in detail in our soil mechanics topic, but here also it is required, and so I'll repeat it. It is the property. It is the property. It is the property that gives that gives that gives molding molding nature to the cement. Molding nature to the cement. Next, as I already explained you about the unsoundness, so I will not repeat it. Setting. It is the loss of plasticity. It is the loss of plasticity. Next, hardness. So generally students will confuse about this hardness and setting. So don't confuse. Setting is about loss of hardness. Then what is meant by hardness? It is about gaining the strength. Okay. Or more basically, it is defined as the resistance to the scratching or abrasion. So hardness for the cement is considered as gaining strength. So that gaining strength can be achieved after having the resistance to the scratching. Resistance to the scratching or abrasion. Okay, so these are the properties. Now let us see chemical composition of the clinker. Chemical composition of the clinker. So chemical composition of the clinker. As we have just seen, clinker is formed by the calcination. Okay, clinker is formed by the calcination of raw materials in rotary kiln. Hence, oxides present in the raw materials. Oxides present. Oxides present in the oxides present in the raw material. Raw material when subjected to calcination, when subjected to calcination, combine with each other, combine with each other to form to form to form a to form complex compounds, to form complex compounds known as Box compounds, known as Box compound, known as Box compounds. As the identification of these compounds was first done by R.H. Box, and these complex compounds were named after him. To commemorate him, these compounds are named as Box compounds. So what are the Box compounds? So there are four Box compounds. So first one, tricalcium silicate, tricalcium silicate, that is 3CaO SiO2, and we abbreviated it as C3S. Okay, we abbreviated it as C3S, and this is called as halite. Okay, this is called as halite in literature. Next, next is dicalcium silicate, that is 2CaO SiO2, and abbreviated as C2S, and in literature it is called as belite. Next, tricalcium aluminate, tricalcium aluminate, tricalcium aluminate, that is 3CaO Al2O3, abbreviated as C3A, and this is called as silicate. Next, tetracalcium aluminoferrite, tetracalcium tetracalcium aluminoferrite. This is 4CaO Al2O3 Fe2O3 C4AF, and this is called as phyllite. So these are the four box compounds. It means the clinker consists of so many complex compounds, but out of all those, these are the major one which influence the properties of cement. Okay. Now you see, tricalcium silicates are formed mainly due to the combination of lime and silica. But for the formation of tricalcium silicate, contribution of lime is more, whereas for the formation of dicalcium silicate, contribution of silica is more. Okay, once again I'll repeat. So both tricalcium silicate and dicalcium silicates are formed due to the combination of lime and silica, right? But for the formation of tricalcium silicate, contribution of lime is more, and for dicalcium, silica is more. Now here for formation of tricalcium aluminate, no doubt lime and alumina mixes are combines with each other for this C3A, but contribution of alumina is more for the formation of C3A. Now coming to the tetracalcium aluminoferrate, contribution from the iron oxide is more. So please make a note of it. Okay, please make a note of it. And coming to these box compounds, function, percentage, and the influence on the various properties of the cement when it is used in practical scenarios, we'll discuss in our next class. Okay, so please revise.